Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 30, we will be talking about the third part of composting, and here we will talk about the different techniques of composting. So, the concept that we will cover in this lecture are on windrow composting, aerated static pile composting, passive aeration methods, in-vehicle composting, vermicomposting, and also we will talk about yard waste composting. So, first we talk about windrow composting. Pre-sorted feedstock is built into long narrow piles or windrows which are turned on a regular basis. So, we have learnt about windrows in our earlier lectures as well. So, this is the image we have shown you earlier as well. So, this is how a windrow looks like. It's a pile of garbage, but before it is left like that, we have to make sure that some amount of sorting is being done so that the final product contains mostly organic matter. So, we have to turn the windrows on a regular basis. As you can see that we use different kinds of machines for that, like this kind of bucket loaders could be utilized. So, the bucket loaders can lift the garbage, lift the compost or that organic matter, and then can make it into this form of a pile. Or there is something called a turning machine, which I will show you an image of that. So, those kind of machines could be also utilized, which can keep on mixing the garbage piles as well. So, this is how a windrow composting is done at the city compost plant at Jubilee Park in Jamshedpur. This is how the composting plant looks like. Now, why is turning done? Now, turning helps to oxygenate the pipe. This we have learnt earlier. Breaks up the particles to increase surface area. Improves the porosity to prevent settling and compaction. Allows heat, water vapor and gases to escape. So, it prevents too much of heat buildup, allows water vapor to escape, some CH4 to escape, CO2 to escape as well. Porosity, it's improved porosity because gradually compost gets decomposes and it gradually settles and it becomes more and more compact. So, of course, when you break it, it becomes more porous, more oxygen mixes, that improves the the decomposition process and so on. Now, the turning schedule, how much I should turn, depends on the rate of decomposition. It depends again on the weather, the climate and so on. Moisture content of waste, porosity of waste and the time you have in hand. So, if you have less time, in that case you have to turn more. As we have learnt earlier, that is the turning schedule. When it is increased, automatically the time for composting decreases. Now, time is very related with land availability. If I have got less land, that means I can store the garbage for lesser amount of time. Every day garbage comes in. So, if I have got less time, less area, in that case I have to complete the process in a much shorter period, right? So, that's why time and land area is very related. So, frequency of turning is adjusted as decomposition decreases. So, gradually the decomposition process lowers and accordingly we have to also change the turning frequency. So, that means again the turning frequency is not fixed, it has to be adjusted. Temperature is monitored and maintained. So, sometimes we have discussed this earlier as well. If the temperature goes beyond 70 degree, it's a all pathogens will be killed and all. So, the decomposition will falter. So, at least we will try to maintain around 55 to 60 degree for a certain 3 weeks or 2 weeks period. That is good enough for production of compost. Leachate generated is collected. Sometimes it is sprayed back, which gives added moisture to the compost. So, or if excess leachate also needs to be treated as well. Now, we have talked about tipping areas, pre-sorting areas and all these things. Then when we have said that we require a compost pad and then there is curing pad, right? So the compost pad is the area where windrows are stacked. Like over here in this particular area, you can see this is the leachate pond, and this is where the windrows are stacked. Each windrow is given a name or a flag which says A1, A2, A3, A4 and A5 and so on. So for 7 days you can see that 7 windrows are created. Now starting from 8th day to 14th day, A1 is brought to B1, A2 is brought to B2 and so onwards. And new waste that comes in on day 7, that becomes A1, A2, A3. In this way, what happens, we keep track on which compost is at which age group, and we know that which batch has reached which stage of maturity, and accordingly we can track the entire composting process. And this transferring from A1 to B1 actually helps in this breaking up of this garbage, and that is also one form of tarning, you can say. So that means the tarning is done via picking up this garbage from here and putting it back over here. So automatically the rest is turned. Now tarning could be also done like with bucket loaders, like I showed you that image in the last slide. Similarly, we can have tarning machines like this. If the garbage is fixed and it's over here, then this just rolls over the garbage and then it can break the garbage over in that location itself. So this is how a tarning machine works. So this particular compost pad is made of RCC and PCC construction, reinforced cement concrete and plain cement concrete construction. Why? Because this is the area where all these machines will operate. The garbage is there to decompose. So we should not allow it to mix with soil and so on, right? And it has to be cleaned at certain intervals. So this entire pad is given a 1% slope, which helps in the drainage through, of course, some drains. And this underground, bottom drains, you can say, from the surface, and then leachate is collected in this kind of a leachate pond for further treatment or even for reuse or spraying this leachate as moisture for the garbage. Waste is held for 5 weeks roughly. Then, so accordingly, we have to determine the area that is required based on amount of garbage that comes in. Maneuvering area for this for people or for the vehicles, equipment area, static pile area for curing after this compost pad, it goes to the curing pad. So this pile area for curing is also required. So as I told earlier, this is 1/4 of the actual compost pad. So this kind of area has to be we have to provide. So this gives you an idea about how much gap is between the different piles, around 1.5 meter. The size of the windrows, you can see 2 meter by 2 meter, 2 meter by 1.5 meter. The height is also 2.5 meter and so on. It depends on what sort of equipment you are using, right? So space between windrows should be sufficient for turning machine or any other kind of equipment, something around 1 to 3 meters. Windrow section could be oval, triangle, rectangle, trapezoidal. So this mounds that you create could be oval, it could be triangular, it could be trapezoidal, and even rectangular, right? So it depends on what sort of machines you are using for creating this kind of mounts. The size, shape and spacing of windows depends on bucket loaders used to build or turning machines and so on, right? So if you are using bucket loaders, you can build very high windows because you can lift the garbage and put it. Turning machines cannot lift, they just turn the garbage. So these are low and wide windrows. Manual labor, usually in smaller scale operation, we can go with manual labor as well. So usually this compost remains in the compost pad for around 35 days, which is around 5 weeks roughly. So you can see that 1, 2, 3, 4, 5, these are the 5 weeks. First week, second week, third week, fourth week, fifth week. That is how A1 becomes B1, then becomes C1 in the different weeks, and eventually we have got the final compost. Then once the basic composting process is over, we do a screening of the compost as we have learnt earlier. Here you can see that 35 millimeters sieve and a 16 millimeters sieve is utilized one after another. And once the compost is done, we can use a 4 millimeters sieve for the final cured compost is sent through a 4 millimeter sieve before it is bagged, right? So initially we do a 3 millimeter sieve and followed by a 16 millimeter sieve. The rejects from 35 millimeter screen rejects are sent to RDF facility, and then 16 millimeter screen rejects are sent back to the windrows as protective cover or insulation of the windrows at the top. So this is the the pre-screening process before the actual curing happens. Once the screening is over, then we leave the compost for curing. So we allow the compost to mature, and the moisture also returns to the standard values of 20%, around 20%, 25 to 30%. We leave it for around 2 weeks, and it takes 1/4 of the windrow size, as we told earlier. And here the microbial activity is considerably low. And what we need to check at the end is what is the oxygen uptake of this particular compost, and the CO2 production rate. If these are low, then of course the manure is ready. The other way to check it is to seal the compost in a bag, leave it for 48 hours, 24 to 48 hours, and see if it is still smelling or odor is coming. If odor is not coming, that means the compost is mature, it's ready for further use. Finally, once the final compost is matured and it's ready, then we can refine the compost by sending it through a 4 millimeter screen. It could be a strommel, it could be a feeder conveyor with a trommel screen, which goes through 4 millimeter perforations. So what we are removing is sand and grit, and all these things could be removed via air density separator as well. So these are the different mechanized systems that we have learned about earlier. So this could be utilized to get very pure compost which could be sold. So over here you can see some images of the compost yard, rain shed, how it looks like. Then this is the screening area where the compost is screened via this conveyor belt, and this is where the bagging is finally happening in these bags. So this is how our overall compost plant looks like. Then coming to aerated static pipe composting. So in one way we can say it's also a windrow composting, but instead of a turning machine or a turning schedule, what we do is it's a static pile. That means we don't turn it, but we put this. It's a aerated static pile. That means we put air inside these piles, right? So you can see the compost with this kind of pipes which are over here. So what is here? This is a perforated pipe. This pipe is a 10 to 15 centimeter pipe. It's a network of pipe is below the compost, and it's connected to a blower which is over here. This is the blower, and this blower can either suck in the air or it can push air, right? So either it's positive or negative pressure. So when you suck in the air, of course it sucks the air from the through the garbage. So automatically air will get inside and eventually reach the pipes, and from there it comes inside. But because the process is sucking process, of course its effectiveness is much less, because it has to be done at a very slow sucking process. A very negative pressure has to be created, a low negative pressure. So automatically air goes in, but it cannot be done very fast. Then compost will come inside, right? But instead the aeration process is, when we are doing positive pressure, we are pushing air, it could be done at a much faster pace. The aeration rate is controlled, or the way this particular blower will operate will be controlled and determined based on the decomposition rate of the compost. And this could be controlled via thermostat. That means there is a temperature sensor inside. It checks what temperature it is. When temperature reaches a certain amount, then we start the aeration, or it could be based on a timer based system. That is, after certain time periods, this particular blower will operate. Or if it could be triggered by temperature. That means when a temperature is reached, then the blower will start operating. So this kind of system the aerated system results in lower leachate generation compared to the other one. A more larger pile could be created, more high pile could be created, as you can see over here. That means your total area requirement would be less. Order is much less because we are using aeration, and post-processing steps also needs to be there. Why? Because this kind of pile is not broken up, so you will see a lot of large particles remaining at the end of the composting process. So that means there has to be post-processing to remove these larger particles, and then either put it back into composting process or send it to a RDF facility and so on. So for feedstock for this aerated static pile, this initial mixing is critical, because usually we should not put in too large material over here. Smaller particles and all should be put up, because this is a static pile, we are not going to break it up. So this initial mixing is important, and if required we have to put in some amount of bulking agents such as your straws, wood chips and so on, so that it creates adequate gaps in the compost so that air can pass through. So that's why bulking agent is added, and in the pre-processing stages we will add these bulking agents, and sometimes we can as we said that oversized non-compostable inert materials are first removed. That happens in most composting cases, but over here we have to be very careful that oversized materials don't remain. Organic matter even should not be remaining, and if required we have to chip them, grind them or shred them, right? We have, as I showed you an image earlier where people put the garbage inside a shredder machine, it will create smaller size components which is eventually put for this kind of composting. Now this is how it looks like. The pile size is like this. It is covered by a compost layer which creates the insulation, and this compost is mixed with wood chips and all this, and evaporated pipes, this is the exhaust fan, and at the end there is a pile of compost which is kept, and if you are sucking the air out, then the sucked air is sent via this compost heap. This acts as a filter, and this filter will make sure that the odor is not there. That means when you pass the extracted air through this heap, the odor will get removed, right? So this is how this aerated static pile looks like. So the pile size depends on what kind of airflow capability we have got, what type of handling equipment we have got, and what kind of material is being composted. The height is around 1.5 to 2.5 meter, and it depends on material porosity, weather conditions, equipment reach. So all this plays a role in determining what height you will create this kind of piles. And sometimes we have to make higher height compost so that in case of lower temperature and all, we want to retain the heat. So in that case, we can create the pile size which is higher in size. The base of the pile is around 4 to 5 meters, and it is covered with a 15 centimeter finished compost or bulking with insulation cover, which is either made of finished compost or bulking agents, and this acts as insulation from outside atmosphere. So odors from exhaust air would be filtered using a compost, and that we make sure that temperature to kill pathogens and weeds are attained. But problem is, even though the central part is heated, because it's static pile, we are not mixing it, but at the periphery heat may not reach. That's why the insulation actually helps in spreading the heat, and also we are putting compost at the end, so that also helps in more decomposition at the outside layers. So that is how this outside layer of compost is actually beneficial in case of static piles. So time taken is 6 to 12 weeks. And post processing, once this is done, we have to remove the bulking agents, because we are mixing a lot of bulking agents because it's a static process, but the compost cannot go with this bulking agents, so we have to remove these bulking agents from this final compost. And trommel screens can be used to do this kind of separations. Then there are some passive aeration methods which are also utilized. As you can see over here, there are pipes which are perforated, and where we don't do turning, but the perforated pipes are put in the compost in such a way so that chimney effect is created. That means hot air rises upwards. So hot air enters from below, the air enters from below, gets heated inside because of the decomposition that is going on and the heat that is produced. Then this hot air rises and it leaves from the top. So this kind of chimney effect is created. So it's a passively aerated windrow, and base is built out of peat, compost and straw. This allows drainage to happen and also allows some amount of aeration as well, and compost is layered on the top, so that the same reasons we can create insulation and so on. Now a variant of this particular method is the Chinese covered pile method, where instead of using this kind of pipes, what this method says is we cover the entire this compost with a clay mixed with straw is placed on top of the pile. So that means this clay mixed with straw provides that insulation cover. then a grid of vertical and horizontal bamboo poles are provided inside this particular pile, and what we do is once the clay dries up, we will remove these poles, and this creates air ducts when we remove these bamboo poles, and this creates the aeration that is required for this particular pile. So here we are not putting piles, but instead bamboos are put in and then removed, so that those air channels are created through which air can go inside this particular pile. So this is called as passive aeration methods. Then we come to in-vehicle composting. So this is where, as we discussed earlier, that in in-vehicle composting, not only food waste but also slaughterhouse waste could be also added. Now, in-vehicle composting, the process itself, as you can understand, it is not open to atmosphere. We use certain sort of chambers or vessels where we do the composting, and these chambers or vessels are responsible for both mixing of the waste, aeration of the waste, as well as providing moisture. And this could be achieved, this entire mixing and all these things could be achieved by either the vessel rotates or the vessel remains fixed. Inside there is a mechanism which rotates the waste and breaks the waste at certain intervals, so some amount, and then it introduces air inside and moisture inside, and this kind of systems could be can be operated, and this could be inside even some certain covered areas or so on, right? So definitely it's a costlier system, but the benefit is that all the things like temperature, this airflow and oxygen concentration, all these parameters could be controlled to our desired levels, right? So that will ensure what sort of final compost will come out. So it's costly, but at the same point of time we can achieve desired quality of the compost by varying the different parameters of the composting process. Now, pre-processing and curing is required before we put the waste inside this vessel, as well as it could be a batch or a continuous feed system. That means the vessel could be designed in such a way so that continuously we keep on adding waste and it continuously gives out compost on the other end, or it could be like we put in a group of waste, leave it for some time, and then we take it out we take out the compost, and then again we put in another new fresh batch of waste, right? So this is where it shows biosolids and amendments are first put inside, it is mixed, then air is supplied, and exhaust air comes out, which needs to be treated, and then the final product comes out over here, which has to be finally cured, and after cured it is bagged and then goes into distribution. Whereas after curing, whatever gases comes out, it could be allowed to go to the atmosphere, or we can even collect it and then treat it. The exhaust air could be treated so that before it is exhausted to the atmosphere. This is how it looks. This is bean composting. These are large beans you can see in the image, and over here this is called a agitated bed composting. I will come to that. So primarily there are two kinds of system. One is a plug flow system, which is the bean composting system. The other is a dynamic system. Dynamic system could be rectangular agitated beds with rotating drums. So it's a rectangular bed, series of beds are there, and there is a rotating drum inside which rolls over this garbage and it breaks the garbage, right? So over here, and this bed is also agitated, right? So it doesn't allows the compost to be stable, and automatically the entire atmosphere is controlled inside this particular chamber. And in wind composting, this entire chamber is environmentally controlled, so that is more controlled system compared to this agitated bed system. So these composting reactors are of different kinds. There are different kinds of plug flow reactors and different kinds of dynamic reactors. So the vertical plug flow system, horizontal plug flow system, inclined rotary drum type, agitated bed system. So these are the different kinds of systems that are there. So in vertical plug flow, obviously this is horizontal. You can also have a vertical system where feedstock is introduced at the top. There is a horizontal rotating screw auger, which is like a rotating arm inside, which keeps on rotating inside this vertical system, and air is fed from the bottom, and that actually helps in the composting process. Horizontal system, feedstock loaded at one end, a steel ram pushes the mixture, air is introduced from the bottom and also exhausted as well. So that means we push the garbage from one side and from the other side it comes out. Inclined rotary drum type, feedstock introduced using hopper from top, so it is continuous introduction of waste. It takes 5 to 7 days and then eventually cured for 2 weeks. So any kind of in-vehicle composting or any kind of composting requires curing. So for 2 weeks we have to cure the compost after it comes out. Finally, we have the agitated bed where feedstock from open is given from the top and agitated by mechanical device. Air comes through the floors. It takes around 3 to 10 days and cured for 2 to 3 weeks. So these are the different kinds of in-vehicle composting systems that we can utilize. Then we come to vermicomposting. This is one of the processes which are adopted in decentralized systems particularly, and these are small scale operations but could be large scale as well. And it's, as you can understand, you can see the earthworms in the picture. So these earthworms actually are the ones which are utilized for the composting process. So vermicompost is the result of the natural digestion process of the earthworms to break down the organic material. So these earthworms will consume the organic material, and the composting and the material which is the excreta of the earthworm is actually the compost. So vermicomposting is a composting process using earthworms. This contains high concentration of nitrates, potassium, calcium, phosphorus and magnesium, and can be applied instead of chemical fertilizers in some agricultural practices. So it's definitely better than normal compost, and it's almost comparable to chemical fertilizer because we have much higher concentration of these nutrients. The worms can be also sold. Once the process is over, you can sell the worms as feed for fishes and all this. And this is suitable for scale up to 50 tons per day. And usually we use thoroughly segregated municipal solid waste for vermicomposting process. The feedstock that is provided for vermicomposting is basically kitchen waste, vegetable market waste, garden waste, cow dung and agricultural waste. So all this organic garbage could be utilized in vermicomposting. But if you provide meat, greasy and oily food and dairy products, this may cause some problems and it may result in bad odor. The different worm species that are utilized, that means earthworm species, some earthworm species are utilized which are more efficient than others. One popular one is this one. This is the red earthworm, which is California red earthworms we call them. This is Eisenia foetidea. So this is length around 6 to 8 centimeter, diameter 3 to 4 millimeter, life of about 6 years and weight of about 1 gram. So this kind of earthworms are utilized. There are other species also. This Perionyx excavatus, then Lampetum morititi. So all these different species are also utilized. Now to do vermicomposting, we have to create a bed or a vermi pit. As you can see, this is a vermi bed or pit you want to call it. Now to create it, first of all, the dimension would be as per the convenience mostly. It could be a single pit or it could be as per the amount of garbage that is being produced. It's 2 to 4 interconnected pits with proper water outlets. It could be a single pit or it could be interconnected pits with a drainage network at the bottom. Maximum height is 0.75 meter, but usually it is much less than that. The CN ratio is around 15 to 35 and 15 to 35 is to 1. Earthworm density is around 1 to 4 kg per meter square on average. So roughly, to give you an idea, 60,000 earthworms in a bed of 2 into 1 meter with humidity 70%, temperature 20 to 30 degree, 800 kilograms of humus is created in 10 weeks. If pre-composting is done, then it could be done in even lesser time, which is 7 to 8 weeks. Now, what is pre-composting? Now, pre-composting is initially we keep the compost for the organic garbage for 2 to 3 days in form of piles or heaps. That the initial phase of this bacteria, microbial activity which generates a lot of heat, that phase is over. So once that phase is over, then we put that compost into the pits so that the earthworms can act upon it. Now earthworms operate best below this at temperatures which are much lower. So if I can do pre-composting, then what happens, the excess heat like 55-60 degrees centigrade will never happen in this kind of pit. So that is beneficial. So that's why it's better to do a pre-composting. But otherwise it's fine. Even if you don't do it, it will happen, but it will take a little bit more time. This process can happen indoors and can be done year round. So in areas with lot of rainfall and other issues, we can go for vermicomposting. So the pit is prepared in layers. The bottom layer is coarse sand, straw and stalks. At the bottom it allows drainage or leachate drainage and all. So 15 to 20 centimeter layer is utilized. So this is utilized as the food for the earthworms. And after that, what happens? We keep on every day when the waste comes in, we keep on adding thin layers of this waste, and the worms gradually move upwards. So we have got this base layer, and then we put layers one above another, and gradually the earthworms move above. Bed is covered to retain moisture and darkness, and pre-composting to dissipate initial heat generated, that we have already discussed. So bed is once the once the layers are done, then at the top we usually cover the bed to retain moisture and darkness, because the worms require darkness, and usually that actually helps the process to go more faster. Now over here you can see the vermicomposting standards given by FCO. So over here you can see the standards are similar to the standards given by for normal compost, but some differences are there. You can see the what kind of nitrogen, phosphates, potash this is required from vermicompost. The bulk density is over here. There should not be any order. Moisture requirement is given, and also heavy metal standards are also given over here. Now on this side you can see that during the vermicomposting process, if somebody is practicing vermicomposting, you may see some problems like foul odor creation, flies, ant infestation, mite infestation, or you can see the worms are moving away or coming out of that particular pit. So these are some of the problems which you have to deal with, right? So in case of foul odor, of course, it may result from either the bed is too wet, or there is not too much air, anaerobic conditions are there, or overfeeding is happening. So in that case, you have to remove excess food, or if it's anaerobic conditions are there, then you have to loosen up the bed, or if the bed is wet, we have to also add bedding to absorb moisture. So that means we have to add certain base at the bottom, so that the bottom base that we talked about earlier, that has to be made properly so that the moisture actually moves out. The flies, if the flies are there, then better to cover it with one layer of compost so that the waste is not exposed. Ant infestation, we can put barriers of chalk or petroleum jelly around the pit, or we can put the pit in water. So all these things could be done so that ants doesn't move in. Similarly, for worms, the bed may be too dry, or it may be packed too tightly, or there may be too much temperature, which will make the worms move away. So that also could be controlled by addition of moisture or making the bed more fluffy. So this is how vermicomposting could be controlled. Finally, we come to yard waste composting. So yard waste composting is like all the garden waste and all these things that are generated, that needs to be composted. But sometimes it takes a lot of time to compost this kind of waste. So instead of making them into waste, we can use them as mulch. So that means we just spread them over the land, and automatically eventually it becomes the topsoil. So we don't want to do transport. We don't want to transport this waste. We want to do it on site. So that's why mulching is a better solution. And usually this kind of waste includes leaves, grass clippings, straws, non-woody plants, and so on. So the thumb rule is, when we do compost, instead of mulching, if I eventually do compost, the thumb rule is to put 3 parts of brown material with 1 part of green material. That means brown material are the twigs, the branches and all this stuff. Green material are the leaves and so on. So 3 parts of brown material with 1 part of green material. So barrel or drum composter is utilized. It's just a simple barrel with holes at the bottom, and a cover is given so that it is not infested by flies or some other kinds of material, other kinds of vector borne, other kinds of vector infestations. Coarse material is provided at the bottom, and alternating layers of brown and green material is put at the top, and the compost is given at the top, again to prevent odor or for preventing infestation of flies and other vermins. The feedstock is usually shredded before we put it into the compost chamber. Usually it is shredded. This will reduce the compost time. Moisture is added as required, and turning is done every few days. Total time required for compost production is around 2 months. So these are some of the references that you can study. To conclude, the choice of composting technique depends on the waste quantity, land area available, climate, energy, cost, operation maintenance requirements, and aesthetics. ঠিক আছে?